Hello, everybody. So my name is Mychaela Falconia. I'm presenting on the Themyscira wireless GSM network connected to USA PSTN. So a first quick note about the naming. I've had people previously raise some eyebrows about the choice of name. Why is your network named after a fantasy comic? So I kind of explained here I explained where the name comes from, so don't need to elaborate further. That should be kind of obvious. But so the technical issue here is how do we interconnect an Osmocom-based network to PSTN? So. So here I describe the problems that had to be solved. What had to be done? Meaning that we have to have real phone numbers for everybody. We're not doing weird extension numbers or phone number net or any of those kinds of schemes. Every user gets a real phone number. You have to be able to make a call anybody you like and receive calls from anybody you like without any artificial restrictions. Same deal with SMS. And basically the last bullet point kind of summarizes the gist of it. Is we just want the overall user experience to be no different from a regular commercial GSM network. Because after all, the whole point of this exercise is to provide the replacement for the commercial 2G networks that are being wrongfully taken away. So if the replacement network is not exactly as good in terms of look and feel user experience as the traditional commercial ones, then that basically it's not good enough. So that's the problem to be solved. And so let's see. Um, so here I also explain what I mean by PSTN, because a lot of people use the term PSTN in a different manner. A lot of people, when they hear abbreviation PSTN, they immediately think about analog copper lines or perhaps digital TDM trunks, basically something other than SIP. And so I've heard the sentiment previously in Osmocom community that everybody in Osmocom is, no, not everybody, most people in Osmocom are used to connecting the network to other networks outside the world via SIP. Okay, so fine and dandy. And so when I was saying, okay, I'm connecting to PSTN, people would think, okay, do you mean you're connected by not SIP, by something other than SIP, like analog lines or something? And so here I clarify, no, I am in fact using SIP, but there's, took them some years ago, I took a whole bunch of philosophy classes in school, and we had a class on the philosophy of Immanuel Kant, the whole idea of the noumenon, the thing in itself. So this is the point I'm making. So SIP is merely an access method, whereas the real thing to which I am connecting via SIP is PSTN, which I define here as basically the total set of phone destinations reachable by either 164 phone numbers. So that should be pretty clear. Again, I'm not familiar with what the situation is in other countries, but it's I need to clarify how the landscape looks like here in USA where I live. So um, now, there was a person recently, someone on OpenBSC mailing list, I believe Enzo, was saying that, like, how there's some other completely different way of connecting to PSTN, which I'm totally not familiar with. And so I was hoping this person would be here to where we could have, back and forth discussion, but I guess they're not here. So, but basically, I can only present about what I know. I can't talk about things I don't know. So as far as what's familiar to me, the method that I've learned is, and also obviously considering budget. I don't have ginormous budget to do this, so I'm looking for solutions that are affordable. So what the telecom landscape in USA is that if you're using a SIP trunk provider, then connectivity in a voice plane, voice only, without SMS, is just insanely, obscenely cheap. I was shocked when I first learned this price, that it is literally 6 cents per number per month. Not dollars, cents. That's how cheap it is to get real phone numbers, the real thing. And so when I learned this, this was a big, architectural aha moment for me, because previously I was thinking, okay, well, am I going to have to use like extension numbers, private numbers for lab test phones, and only give a real 10-digit number to those users where like a real human user is involved? But when I learned how cheap it is, I was like, well, if it's that cheap, there's just no point in doing anything else. Why bother with extension numbers or anything other than a real 10-digit phone number to every, even just a test SIM, because it's so cheap, right? So, and here I also have to point out that all of the USA, the entire country, is now treated as a flat rate. It used to be decades ago, there were local calls and there were long distance calls. You had to pay for long distance calls. And based on someone's phone number, you could immediately know which part of the country they're in. Well, now that's not the case anymore. We have number portability. People take their phone numbers with them wherever they go. People routinely live for years and years and years in one state with a phone number from another state. They just brought with them and never bothered to change, because why change? Um, and in terms of costs, even network topology, pretty much all of USA, which is a very large country, is being treated as essentially one locality flat. So now the part where things get really difficult is when you want to extend from just voice to also have SMS. So the problem with SMS is they have this weird classification of P2P versus A2P, where P2P stands for person to person and A2P stands for application to person. So when Alice takes her phone handset and sends a message to Bob, that's considered P2P, person to person. But these days, you have a lot of, like, doctors' offices giving appointment reminders via text, and people use SMS to order their pizzas and get a message saying your pizza is ready to pick up, and all those, uh, in my mind, they kind of misuses, abuses of technology, but people are doing this all the time. And so all of those are the use cases for SMS and SMS marketing, etc. All of those are called A2P, for application to person. And this distinction becomes important because when you are just a low budget user, low volume, low budget user looking to interconnect to PSTN via SIP, then you have lots and lots of these providers that give you access to the voice network for this insanely cheap price. Of course, I only mentioned so far the price for phone numbers. You also have a per minute charge, but it's so tiny that it's not even worth a bother. But so most of these providers will also offer you SMS for also very affordable prices. But if they classify you as A2P, you cannot get P2P SMS classification from any of your typical average Joe SIP VoIP provider. And so that becomes a problem for an application like mine if I'm running a GSM network and every person who gets a phone number on my network is presumably a human user. I mean, yeah, I have some test SIMs for lab use, but aside from lab testing, the primary use case is real human beings having good old phone handsets. That's a period DPL10. So having good old phone handsets, just using SMS traditionally, we need for them to be correctly classified as P2P. Being If we were to be classified as A2P, that's a misclassification. And I'm not sure exactly what will happen if a P2P user gets misclassified as A2P, but all I know is just going to be bad. Just don't go there. And so I was looking for, okay, well, how can I get the correct P2P classification? And I found this one and only one white market provider, Bandwidth, and I filled out a contact form, and I had the sales representative call me, and we had a nice little discussion. And then she says that the monthly minimum spend is $2,500. So in other words, they don't want to do business with you if your business volume is going to be less than $2,500 per month. Per month. And it was just some of this typical German internet. Sorry. Okay, I don't know. So uh, but anyway, so I was just so shocked to hear the kind of price. And I even told her, I said, okay, our location here is Ramona, California. You can look it up on a map. You can look US Census Bureau official numbers for population of this town. The town is small enough to where even if there were no mainstream operators, if my Themyscira wireless operation was the only provider in this town, then we still would not have enough total population to meet that volume requirement of $2,500 per month business volume. It's like what? So this is where community had to come to the rescue. And I'm glad that Denver is attending here today. This slide that's on the screen right now, yes, Denver and I coordinated this slide ahead of time. So, Denver, as we discussed, would you like to jump in for a few minutes and give us just a little bit of a.
Yeah, I can describe a little bit if you're interested. I mean, I'll
Yeah,
just very quickly describe JMP and then the other parts here. So JMP provides phone numbers that you can use from, generally speaking, from your Jabber ID. And so the idea is that you can use whatever Jabber or XMPP client you want, and then do all of your calling and texting, and also things like picture messaging and group texting, which some people like, but of course some people prefer not to use, but it's up to you. So that's just a general overview of what JMP is at jmp.chat. But we do, because of our volume, have an agreement with Bandwidth to provide the vast majority of these services. So that was one of the things when we connected that was of interest. And Bandwidth does provide some of these P2P SMS services. And we did have to do some amount of petitioning to ensure that we were classified as P2P, because the default is A2P, and they really want you to prove that you're not doing any sort of A2P like things. And we even occasionally have them tell us, "Hey, we have started blocking messages from this number because it looks like a business communication." And this was, a situation. I think someone was sending links to spreadsheets over SMS or something like that, and they call that business use. So we have to be very careful about what we do, and it's kind of frustrating because I feel like people on Verizon or AT&T or the other big carriers in the U.S. probably get away with sending presentation links over their cell networks, but anyway, we're too small still to be able to push in that direction. But yeah, the A2P thing is very difficult because you need to register before you can do anything over A2P these days. So you need to define what kind of thing you're doing. and it's very difficult. Even things like notification when a server goes down or something like that, there's no category for that sort of thing. So you kind of just have to hope your messages don't get blocked, or something like that. So of course, what is being done in this 2G situation is very much exactly P2P, and so we had no concerns with it being used for that. But we are also very happy to be able to provide this because yeah, we don't uh, we we have this ability to do all of these things, and while we use most of them, there are some other things that are very important for other use cases, like the P2P SMS over standard APIs, and I think that's what's going to be talked about a little more here. So I think that's generally the overview there, and I'm happy to add anything as we go on, or otherwise, or add anything that you wanted as well. So yeah. And yeah,
Okay.
thanks also for having me here.
Yes, well, thank you, Denver. So yeah, so Denver just explained what the GMP service is, and so we were able to work out an arrangement where I get direct access to bandwidth's SMPP server. So the protocol they use to deliver SMS, yeah, well, both to deliver incoming SMS and to accept outgoing SMS is SMPP, which unfortunately it's not as pure and transparent as a native SS7 map connection, but I have no idea how to get those. And once again, there was this person on Osmo BSC, sorry, on OpenBSC mailing list naming is another thing. No, we don't have OpenBSC anymore, but mailing list is still called OpenBSC. So on the OpenBSC mailing list, there was this person just in the weeks leading up to this presentation who was talking about how supposedly there's a different way, how there are these companies which give you direct native access to the SS7 map. You don't even have to go through SMPP. Well, I mean, I'll be all ears. I would love to know about those options. But again, that person is not here today, it seems. So, oh well, maybe they will be willing to do another presentation on their method later. But so I'll have to continue with what we have right now. So what we have right now is, um, yeah, we use hetero or hybrid routing. So typically in the USA telecom culture, when someone has a 10-digit phone number, because we have, oh, okay, so Harald saying, um, yeah, Harald says the problem with SMS map connectivity is that just okay, you still need SMS interworking agreement with all the target MNOs. Okay, well, yeah, like I said, that's an like contract with operators. I get that. Yeah, that's an area where I am basically ignorant. I just don't have the knowledge in that area yet. So, what I was saying here is in the USA we have local number portability. So someone who has a 10-digit phone number can take that number to their carrier of choice. So people move phone numbers routinely back and forth between different mobile carriers. Supposedly, people have even been migrating landlines to mobile. I don't know if you can do the other way around, but I'm not familiar. People have been doing those things. And of course, with VoIP providers, people can take a number that was originally mobile, like with a mainstream carrier, and they can port it over to a VoIP operator, maybe even the other way around, not sure. So basically, for every 10-digit phone number, there is a routing information somewhere in the PSTN cloud that says where is this number supposed to go. And there also is an option to have a hybrid routing to where calls will go to one provider, whereas SMS and presumably MMS, although I don't really care about MMS, will go to a different provider. And that's exactly the setup that I run with currently, to where I use bulk VS for voice and GMP through bandwidth GMP combination for SMS. So that's how currently hybrid routings. So um, most of this presentation is going to be about voice. SMS is kind of tangential. So in the voice plane, here I explained some terminology. This terminology is so non-obvious. I don't know why they came up with it because intuitively it seems reverse. So they use the term origination provider to mean the company who handles your incoming calls, and termination provider is the company that handles your outgoing calls. So it feels reversed, but for whatever reason, this is industry standard terminology. Everybody in this field calls it that. So I explain what they are. So this is my current arrangement. Bulk VS used for origination and termination within NAMP, North American Numbering Plan Territory. But for if I want to call to Mexico, Russia, Kazakhstan, whatever, all the little, you know, attempts at TFO I've been trying to do, all that goes through NVO Direct because bulk VS, as wonderful as they are, they do not provide termination service to anywhere other than +1 country code. So bulk VS, in my experience, they are the most affordable, most straightforward, easiest to work with, but again, they offer everything in the voice plane other than international termination. So for international termination, you have to go to a different one. And with Envio, I've only been playing around a little bit with it. I probably haven't fully tuned it correctly, so it's still kind of so-so in terms of reliability. But so far, international calls don't really have much of a use case for it other than playing around. And now we get to the technical part, the part that's going to really matter here for interconnection, is the voice codecs. So I don't know what the situation may be in other countries, but at least with all of these providers that I just listed, all of them support your G.711 codecs, PCMU and PCMA, also known as MU-law and A-law, and they also support G.729. But they do not support AMR. They do not support any of your GSM, FR, EFR, HR codecs, none of those. So basically, if you operate a GSM network, or more generic, not even GSM, but any kind of 3GPP cellular, even if you run a 3G network, where it's all AMR, same thing, you still have to transcode. So there is no possibility of an interconnection without the transcoder. Transcoder is mandatory. And then the next bullet point, transcoding to what? There was it about 2 years ago here on OsmoDevCall, we had a presentation by Keith from Rhizomatica doing a little screen sharing peek at the infrastructure and how they do transcoding. And I saw in the showed SIP logs how they go to those compressed codecs like G.729 and possibly others. I'm not doing that. Not doing any of those. Because again, the objective is to replicate the service quality standard that was always provided by traditional commercial cellular operators, and those most certainly do not use compressed lossy codecs on a backhaul. Because if you think about it, if you try to use a backhaul with, say, G.729, that means your transcoder has to decode from one lossy codec, being AMR or one of the GSM codecs, and then re-encode into a different lossy codec, this time G.729. So now you've got two lossy codecs running in tandem. That's bad. So not doing that here. So basically, the design or policy decision is that all outside interconnection always uses either PCMU or PCMA, 64 kilobits per second, just a very simple encoding, nothing else. That's it. That's just how it's done. Which simplifies technical architecture quite a bit. Uh, so let's see. And now we come to our first ASCII art diagram. So this diagram on the slide should be very familiar to most people in Osmocom, because this is like the standard officially recommended architecture that everybody other than me uses so far. And so when I first started looking into this back in June or so of last year, when Denver first explained to me about he was the one who introduced me to bulk VS and explained all the basics. At first, I was thinking that I would be replicating the architecture that's on this slide right here. And I was thinking, okay, for PBX, is it going to be asterisk or is it going to be free switch? And I looked into both of those. They're spaceship complexity, and obviously they're not specifically written for the purpose of connecting a GSM network to PSTN. That's just not what they're written for. They're very generic, highly general purpose software, but it's complex. And ultimately, my philosophy is if I'm the operator of the network, the buck stops with me. Buck stops with me is kind of an American expression. I don't know if it will be familiar to non-native English speakers, but basically means where the responsibility ends. So the responsibility ultimately ends with the operator. So if you are the operator of a network and you have users depending on your network, even if you're the only user, you with the user hat on, still depend on that network. And at that point, it doesn't matter what software you use. It doesn't matter, I'm using free software from such and such distribution. Well, fine, that's your little internal detail. But ultimately, the operator has the final responsibility for everything that happens on the network. So if I were to use an outside piece of software, which I did not develop myself, then I have to fully, thoroughly understand that piece of software. I have to become an expert on every little detail of that software. I mean, I'm already, of course, have to do this with Osmocom. Osmocom is already pre-existing software which existed long before me, and which is a critical, essential component to running the GSM network. And yeah, it is extremely complex, and it was quite a learning curve for me to find my way around Osmocom CNI, but at least it is a necessary part. And Osmocom CNI, unlike Asterisk, unlike FreeSwitch, unlike all of those things, it is specifically written for the purpose of running a 3GPP style cellular phone network. So at least it's purpose-made software. But using this off-the-shelf, non-GSM specific, non-3GPP specific, non-cellular specific PBX, I don't like the idea. So someone could say, okay, Mychaela, why you can just write a replacement PBX. Keep Osmosip connector, but just write a replacement PBX of your own, called Freeclipse PBX or something, right? Themyscira PBX. But yeah, of course, I thought about that option briefly, but that doesn't make any sense because the big problem is still this part of the diagram right here, this internal SIP lag, to where if the custom software is going to be written in this box right here, then this box does not have direct access to this. It only has access to this. So this internal SIP leg is kind of an unwanted middleman at that point. So my idea was, okay, can I just get rid of this unwanted middleman? And so this is this diagram is what I sought out to do. So of course, this diagram is very high level. This is not a detailed final design. This is just the basic idea of what it is that I sought to accomplish. So uh, and, and so basically the big box here has to do all three of those functions. Local call switching, in other words, from one GSM subscriber to the switch back to another GSM subscriber. Then for inbound, you come from here to GSM, and then outbound, you're from GSM to outside world. So all three paths have to be handled, but that's just like a requirements definition. That's not an implementation detail. So um, So here on this slide, I explain in more detail why I wanted to get rid of that third leg, that internal leg that runs from Osmosis connector to the PBX. Is one reason is local call switching. So let's say Alice and Bob are both subscribers on the local GSM network. So with Osmosis connector, what you're going to have is even for a purely internal call, you're going to translate from native GSM call control into SIP. You're going to do the switching in SIP land, and then you're going to translate from SIP back to MNCC for the other call leg. Well, there is no such thing as a lossless conversion. The paradigms of GSM call control based on Q.931 or whatever it's called and SIP are very, very different paradigms. There is no direct one-to-one translation. Whereas if you have a fully local call switching, keep it within native GSM land, then you can do CSD very easily. If I want to do a CSD call from one mobile to another, that it becomes very native and straightforward. You can pass user to user information element. So, for example, there have been hacks, and I was even involved in those hacks some years ago, where some people have done almost like a roll your own CSD like over voice channels. What people would do is they would establish a regular a call which the network thinks is a voice call using GSM FR codec, usually just plain old FR1, and then they would throw a switch and start passing non-speech data bits through the connection. So this I was involved in making that work with Calypso back in 2016. I'm sure probably other people have done it with other MS implementations too. Is you invoke this special feature in the DSP where you cut out the voice channel and you start feeding your own bits directly into the GSM 5.03 channel encoder, the 260 bits per frame, and then the network, thinking that it's just a voice call, transcoder free, will pass it through to the B leg of the call where it goes on the downlink, and then the other entity on the downlink just reads those bits out of the DSP or MS implementation specific mechanisms. But as far as network is concerned, it's just they think it's a speech call. But then how do you negotiate this mode? Well, if you have a fully transparent, what if says, but such data call would not survive transcoding. No, of course it would not. Yeah, no, this would not survive transcoding. It is a total hack. There's no legitimacy to it whatsoever, but people do it nonetheless. And but another idea is to have user-to-user signaling. So the call setup message in CC protocol has this optional information element called user-to-user or something, and the built-in the internal MNCC handler within Osmo MSC passes it right through to the destination call leg. So it's taken out of uh, the CC setup message on one leg and goes directly to the C setup message on the other leg, passing through MNCC structs. And someone could potentially use this user-to-user information element to say, hey, I'm setting up this weird call, and it might tell the other side, yeah, so it's a Morse code beep for transport. Yeah. So, but anyway, the point I'm making here is that it's nice to be able to preserve end-to-end transparency in the signaling plane, because, okay, so even with the Osmosis connector and external PBS, if there is no transcoding, if both sides use the same codec, then the RTP will still be transparent, but you definitely do not get transparent signaling for call setup. Whereas here you do have transparent signaling if you are one GSM subscriber calling another GSM subscriber. Then okay, so if it is a gateway call, if I am talking to the outside world where I am doing transcoding and I am doing conversion to SIP, It's like how many if you are a zookeeper, or if you're operating a circus, how many animals would you rather manage in your circus? Would you rather manage two animals or three animals in your circus tent? That's kind of the question here. Um, so there are two animals in the circus tent which absolutely have to be here. One is being the GSM local side with CC and MNCC, and then the other absolutely necessary animal is the external SIP leg, the SIP leg that goes to the outside world, to whichever provider you're using for this cheap, interconnection to PSTN. But why do you have to add a third animal to your zoo? Being this extra internal SIP leg that only runs between OsmoSIP connector and PBX and nowhere else. That's just an unnecessary complication as far as I'm concerned. And then, okay, so signaling events, error conditions. Let's say, I need to signal some error condition because my transcoding gateway is out of resources and it's unable to connect a call because of resource limitations. If I have direct connection to MNCC, I can report the appropriate cause value in native GSM CC cause encoding. Whereas with the obsolescent connector architecture, a PBX signaling an error has to signal that error using SIP error codes, but then those SIP error codes will never go anywhere other than to be translated into MNCC. So again, why the middleman? Why not speak MNCC natively from your custom software? That's kind of my idea. And then finally, we get to DTMF. So I'm a perfectionist. I like doing things properly just for the heck of it. So I have actually observed that, okay, so I guess backtrack. DTMF duration. On a plain old analog, like POTS analog phone, you literally, you press the button and the tone starts, and you lift the button, the tone ends. So the duration of each DTMF tone is how long you hold down the button with your finger. And GSM architecture replicates this approach with a start DTMF and stop DTMF signaling. So on a standard handset, and I've tested it, using standard existing off-the-shelf firmware, not just mine, but everybody else's. Uh, you press down the button during a call. You press a DTMF button, and there is a start DTMF message that goes out. And then only when you release the button, when you lift your finger off, that's when the stop DTMF message comes through. And so at the time when the start DTMF is issued, the mobile station, the phone, has no way of knowing how long the button is going to be held. And of course, all the intermediate network elements like Osmo MSC, Osmo SIP connector, etc., they also have no way of knowing how long the button is going to be held down. But in the interface used from Osmo SIP connector to the PBX, this third leg that I'm trying to get rid of, there they use a SIP info method to signal DTMF, which is all fine and dandy, except that you have to indicate your duration up front. You have to indicate up front in that SIP info method how many milliseconds is your DTMF tone going to be. And Osmo SIP connector has some kind of hard-coded number there, so the true duration of DTMF is lost. And as I see it, this is not a bug in Osmo SIP connector. This is a limitation of the architecture itself. It's having this SIP third leg interface between the SIP connector and the internal PBX. It imposes this straitjacket constraint. So that's why my solution is just get rid of that third leg. So now we get to the actual implementation, what I've actually built. So this is just the first half of the diagram. The next slide will have the other half because it's a big diagram. So Here you see the control signaling plane. This does not show RTP, but the entire control signaling plane is shown on the slide. So I am using MNCC as my native internal language. So it's all being all these interfaces, this interface right here and these additional interfaces, they're all Unix domain sockets. So this interface right here is defined by Osmocom because I am talking to standard unmodified Osmo MSC. Well, I mean, I do have a few local patches there, but they're not essential. They're just like bug fixes. So even without local patches, this will work. There's no fundamental change. So this is an Osmocom defined MNCC interface. These additional interfaces over here, these were defined by me, but they are exactly the same almost as the native interface here Osmocom defined. So basically the same structs. All of the binary structures of MNCC are passed through by this switch to these other components. So this component here named SEMY-MNCC, it is literally an MNCC message switch. It is a switch that passes through MNCC messages. And then there are additional local Unix domain sockets for other components to connect to with the exact same MNCC. So this was the first one to be written, just of course a command line test program. So on my network, what I can do, I can connect just one phone. I connect a single phone to my GSM network, don't need a second phone, and I can type a command line. I type them-test-mtc space and a phone number, press enter, and the phone will ring. Of course, there is no actual voice traffic. So, when I do what I just said, uh, because this thing does not generate any kind of RTP stream, the BTS handling this that eventually handles the call will see nothing on its RTP input. So, thanks to all the patches that we already got merged into Osmo BTS, the stream going down to the mobile station will be all BFIs. And then the receiver in the RxTTX handler in the MS will then generate silence because it just sees BFIs and nothing else. But the signaling path is exercised when you do this. When you do what I just said, you can see exactly what the MS returns in its bearer capabilities information element. You can see which version it supports. You can see the flow when it says call confirmed and call alerting and then eventually call answered. The whole thing is just seen from the command line. And obviously this path exercises the ThemBioMSC switch, exercises interface, exercises all the Osmocom components in delivering the call. So that was the first thing. Then the next thing to be developed was the inbound gateway. So we have a call from the outside world from PSTN, comes in through SIP. This thing handles it, converts it to GSM call control, and then connects to ThemBioMSC and asks ThemBioMSC to ultimately just pass through to OsmoMSC. And then the last one was the outbound gateway. And so here what happens is ThemBioMSC, when it gets a call from OsmoMSC, is it says, okay, is this a local number or is this a non-local number? So if it's a local number, it is switched right back here. Or if it's a non-local number, it goes out this way, and then this process converts to outbound. SIP goes to a termination provider. And now we have the RTP plane. So with the RTP plane, this basically is a software component. This is a highly software component, the MYMGW. And so it receives, just like Osmo MGW receives control from Osmo MSC. So basically, this Osmo MGW is coupled to this Osmo MSC. In the same way, these two guys, ThemY in and ThemY out, they control ThemY MGW via my own ad hoc again, not the Unix domain socket protocol. And so I remember when I was first describing this architecture to Vadim some months ago, like, oh, why did you write your own ThemYMGW? What's wrong with OsmoMGW? Well, the answer is OsmoMGW is still there. It doesn't go anywhere. It's still connected to OsmoMSC just like before. But we have to have this additional MGW because it does all this highly custom work. Of course, transcoding and DTMF. These things happen here. Another thing that's very important to point out, this component is not general purpose. It is highly specialized. It is also asymmetric. So it's got a GSM side, it's got a PSTN side. The reason why this is important, it's a contrast with Osmo MGW, because in Osmo MGW, when you have an RTP bridge endpoint, at least as far as I'm aware, someone please correct me if I got it wrong, but it looks to me like it's fully symmetric. You have the A side and the B side, there's no difference. But this custom gateway is highly asymmetric. So the GSM side is designed to only speak GSM codecs and nothing else. And the PSTN side is designed to speak PCMU and PCMA and nothing else. So this is a highly asymmetric specialized gateway. So of course it does transcoding using all those libraries that I presented on 3 months ago, the Themyscira codec libraries. Well, this is where they're used. And DTMF also happens here. So I do DTMF in band. Yes, I know, of course, that another way to do DTMF is, what is it, RFC 2833, which has been superseded by RFC 4733. I'm aware of those mechanisms, of course. But in the present case, I decided it was just an unnecessary complication to introduce those, because on the PSTN side, I'm not using compressed codecs. I am not using G.729 or any of those. I'm only using PCMA and PCMU. So when you're doing PCMA and PCMU, then doing DTMF in band, in other words, actually emitting waveforms of the two overlapped sine waves directly into the sample stream, that is the most native, simplest possible way. So this is what I'm doing. So in the ThemY architecture, what happens is, the user uh, the user presses the button on the phone, the TMF message that goes through the signaling channel, goes through fetch, then it goes through ABS RSL, and then from ABS RSL, where else does it go? Yeah, it passes through the A interface ultimately to Osmo MSC, and then from Osmo MSC. Osmo MSC then turns it into a start DTMF message encoded in MNCC. It goes to ThemY MNCC. ThemY MNCC passes it through to ThemY SIP in or ThemY SIP out. These turn the MNCC start DTMF message into a custom command for ThemY MGW, and eventually it gets here. And so this then flips its state machine, says, okay, I'm going into DTMF output mode, and it starts suppressing the output of the GSM speech decoder and replacing that output with the DTMF waveform going out into a PCMA or PCMU. And when the user lifts her finger, the DTMF stop message passes through the same signaling path, ultimately ended up here. So this is essentially where the signaling plane and the traffic plane merge for the purpose of DTMF. So this is how it's implemented. So let's see what else. Okay, so here I describe how the software is implemented, basically coding style. Now, okay, maybe coding style is the wrong term here because I guess people use the term coding style to mean things like, how many spaces you use spacers or tabs, and where you put your braces and whatnot. So in terms of coding style, my personal coding style is very similar to Osmocom coding style as it is. There's very little difference. But when I say when I say programming style, it goes beyond coding style. It's more like which dialect of C are you using? Are you using like really really modern C, or are you using an ancient 1980s Unix, early 1980s Unix KNRC? So I use the latter. So um, that's how the software is coded, and I don't have any dependencies. I'm not using Sophia, SIP, or whatever. I literally implemented SIP 100% from scratch, plain C, no libraries whatsoever. And yeah, this is transcoding. And transcoding is done using the GSM codec lib package, which was presented earlier. And now, of course, there is a downside. The downside is that I currently don't have VTY or any of those nice things, which are kind of important because these are long-running processes in a production network. It's kind of important to be able to interrogate the internal state, poke around, see what's happening, debug. So the lack of VTY is definitely a problem. So at this point, now that the software has already been written in this programming style that already exists, it's kind of hard to say which would be more difficult, converting everything to use Osmocom libraries or just implementing my own very, very, very primitive VTY-like mechanism using Unix domain sockets instead of Telnet. Still waiting to decide. But I only very recently figured out a way to link with Osmocom libraries without auto tools, because going through auto tools and everything, that's just so different from my 1980s Unix paradigm. But at least I figured out a way to do it, which we'll get to for SMSC. I am doing it a slightly newer way. With for the SMSC, I am linking with Osmocom libraries, and I am using the slightly newer NCC dialect as necessary, but I'm not using auto tools. So that's the situation there. Um, So now this, of course, as we get to SDP. So I know there has been a lot of tension, unfortunately, between me and other Smacom developers on the subject of SDP. So here I am just trying my best to explain why I'm doing things the way I am and how I do use SDP currently. So, as I explained on the slide, of course, I am using SDP as necessary to talk SIP with the outside world. But because it's all PSTN side as opposed to GSM side, it's all PCMU and PCMA. In the entire ThemY architecture, there is no need whatsoever to ever use SDP to describe GSM side. So just like a couple slides ago, was it yeah, on this slide, how we have this asymmetric, so we have these two RTP streams, right? So we have one RTP stream that has GSM codecs. We have a different RTP stream that has PSTN codecs. These are two separate RTP streams. So I only use SDP to describe this RTP stream, but I never, ever, ever have a need to use SDP to describe this guy right here. It's just not needed. Mm, so and again, all of the software was developed before the SDPification patches were merged. So back then they were on a branch, and I was like, well, having only a finite number of brain cells to devote to this, and having just so many other components that had to be developed, just didn't really look into the SDPification. And then, so when eventually those patches were merged, I was like, oh God, what do I do now? Um, so that's kind of the situation we ended up with. So here I describe how to use it. So let's see. All right. So people were saying that the reason why the SDPification patches were merged and why most people in Osmocom consider them to be a good idea is people would say that prior to the SDPification patches, codec selection was broken. Well, for me, it's not broken. For me, codec selection without SDPification using the February 2023 release of Osmocom CNI, codecs work very, very well. And I explain here exactly how it works. And I'm sure that I don't need to like go through it by detail. People on Osmocom are gonna know exactly what happens here, but just you see the slide explains how it happens, and this is irrelevant to my setup. It's just the FR and FR1, and so here I explain how why it works so well in practice. So most calls in real life usage are to and from the outside world. And if it's an outside world call, then like I say, there is only one GSM call leg. It's always transcoding to PCMU, PCMA. So there is simply no possibility of codec mismatch because there is nothing to mismatch against. So that should be straightforward. Now, when we have one local MS to another local MS, then there is a possibility theoretically of a codec mismatch, but not in practice because I explained here, that in reality it all ends up being EFR. So yeah, I have this one phone, Nokia 2190, which is very, very old, like 95 or maybe 96 at the latest. And it there is a possibility that phone might not support EFR. It might be FR1 only, but so far I'm unable to bring it up at all because it does not accept my current SIMs. So I have to, and yes, I made the rename. So Harold got thinks it's all worked out. So the project which I previously incorrectly named as SimTrace 3 is now called FreeCalypso SimSniff. But in any case, it needs to be developed a little bit further before I can debug why in the world is that Nokia 2190 not working and how to make it work. But until then, I don't have a phone that's incapable of EFR. They all do EFR. And so if they all support EFR, there is no codec mismatch. So that's what's currently happening. And so, but of course, there is a need for future improvement. My current solution, I'm not saying it is perfect. I'm not saying it is ultimately correct. I'm fully aware of the need for improvement, just like, I say right here. Now, a little detail that might not be obvious. So if you have one phone that only supports FR1 and another one that normally would get EFR, in this combination, there is absolutely no benefit to be gained from transcoding. If a network were to transcode in this combination, it would only be worse than doing FR1 end to end. So here, very clearly, transcoding is not the right choice, and codec matching is the right choice. But there are other scenarios, like I described with AMR, especially half rate, where transcoding might not be such a bad idea. And the reason why I'm including this information here is, to give food for thought for other Osmocom developers, further improving codec matching situations. Just so you guys realize that there may be times when matching the codec between the two legs might not actually be the best course of action. Sometimes it might be better to transcode. Just like here, for example, let's say you have a network where you have a high number of users and the radio resource usage is a concern. And so you're deploying half rate channels with AMR HR to get more cell capacity. And you got one pesky user who has a really, really ancient phone that only supports EFR or FR1, whatever. And let's say you want to be nice to the user and not ban them from your network altogether. Well, okay, then you have a call between this very old phone user and more modern phone users. Do you switch the more modern phone user from half rate to full rate, or would you rather keep the newer phone user on the MR half rate and transcode in the middle to save radio resources? So, food for thought. And also, this other thing that Vadim pointed out to me earlier is that AMR has a better performance. Let's say if you have poor radio conditions, if your carrier to interference ratio is not that great. So AMR is an improvement over old-fashioned FR/EFR codecs in that it handles the situation better. And so, well, okay, so now let's say you have a situation where on one hand you have one call leg that would ideally get AMR full rate, but then you have the other call leg which is stuck at legacy EFR. What would you rather do? Switch the AMR call leg to the older codec and potentially give that so let's say if the AMR user is far away from the base station, has like really bad radio reception, whereas the user with FR/EFR is right next to the base station. In that case, transcoding will give you better end-to-end call quality versus forcing FR/EFR on a user who is far away from the base station and would benefit from AMR. So all of these things are, and so these complications are also the reason for why I am not using AMR currently, because my current conditions, the conditions in which my network operates, in terms of radio, well, one, I don't. The user count is extremely low, so there's no congestion is not a concern. There's no need for half rate channels, and even with this carrier interference ratio situation, well, the way my radio conditions work out is that when you're too far away from the cell, nothing works. Like even the paging channel, receiving the paging channel fails, and at that point the phone is completely unusable. So at that point, it doesn't matter what you do with traffic channels if you can't even make a call in the first place. But once you are close enough to where you are able to do signaling and you're able to receive paging channel, at that point, the call quality is also, channel quality is good enough to where you can use an older codecs without any problems whatsoever. So that's why, I just made my network so much simpler and that, okay, I'm not going to do AMR, I'm only going to do EFR. Simplification. So, but of course, doing AMR would be far more complex. Um, so the other thing here they wanted to point out is there have been discussions in Osmocom as to what is the correct way to handle codec mismatches. So people have been saying, well, should we maybe delay the assignment on the destination, on a call leg B? Should we maybe delay the channel assignment until we have worked out a codec match? Or as an alternative, what if we pick the wrong codec initially? Can we just reassign? Well, I'm making the argument that reassignment is the only correct way because of call waiting. So the alternative approach, where we do more work of matching codecs end to end, and only then later doing a late assignment. Sorry, I guess the proposal by other people was that even on the call A leg, on the mobile originated call leg, I think someone made a proposal where the channel assignment on that leg will be delayed until we know the codec capabilities from on the far end so we can assign an end-to-end matching codec. That was the proposal. And yes, of course, it can be done, but it doesn't really solve the problem because the reason why the reassignment, the subsequent reassignment after you assigned wrong initially, is a much better way is because the reassignment is the only way to do call waiting. So here I have this bullet point diagram, stepwise what happens in a call waiting scenario. I mean, I don't need to, I'm sure you can read, I'll read the slide and see what happens here. So I don't see any way to correctly support this call waiting scenario without doing channel reassignment. Like here, literally, as you switch calls, in this scenario, you will have to do a codec switch every single time. So if we are doing transcoder free operation in our networks, then if you want to have call waiting, then this is what we need to do. So obviously this is all for future development, but I wanted to make Osmocom developers aware of this situation so we can plan appropriately. Um, so now I'm stepping away a little bit from the topic of codecs to other issues that arise when you are connecting your phone, your GS Osmocom based network to your host country's PSTN. So what I saw here is this lack of guidance. So as it is, the MSISDN entry in the OsmoHLR database is just a number. There are no TON or NPI fields. I was like, okay, well, fine, but is there some guidance as to what is the correct way to enter MSISDNs? But apparently there is no guidance. So it looks like the whole thing was designed with the assumption that the numbers entered into HLR are going to be private extensions. Apparently people haven't really put in the thought into how a real genuine outside E.164 number should be entered into OsmoHLR, so I had to improvise. But again, there are these open questions. Like even in the US, there are two possibilities. I could have given it like this, this option, or I could have done it like this. Both seem valid, but and so I explained this is what I ended up doing. This is how I did it. But for people in other countries outside of North America, for them, this question will probably be even more acute than it is for me. So here I use the example of Mexico, where the country code for Mexico is 52. So if someone in Mexico wanted to replicate what I've done in USA, and they were going to connect their phone network to the Mexican national public phone network, where they have a real 52 country code phone number for every subscriber, do they enter it as 52 and then 10 digits? Because they also have 10-digit numbers after the country code, just like in the US. So do they enter as 52 followed by 10 digits? Is that how they should enter it into Osmo HLR? Or should they use whatever is the convention inside the country, which to be honest, I'm not very familiar with. I'm still just a visiting tourist there, so I haven't. Okay, so yeah, so Harold says the only proper solution would be to store not just the digits, but also the type of number, possibly also the NPI number and plant indicator. Yes, I agree. I fully agree. I just didn't know what the thinking was amongst more senior decision making Osmocom developers. So just didn't know that. But yes, I agree that would be the proper solution. But for now, when we don't have it, every operator kind of has to improvise and decide what's best for them. So, I ended up implementing this 11-digit convention. So, um, then we also have this additional database. So what I am describing here is get a little bit of juice. Give me a moment. So this should be basic fundamental theory of phone switching even outside of mobile. So when you handle a call, the very first switch decision you make, is this a local call going to another subscriber right here in my town, or am I going to the outside line? So this was, I mean, the analog step-by-step switches and crossbar switches and whatnot. They all had this type of switching decision. And again, in old days, they would answer the question by the structure of a numbering plan. But as I explained here, when you are a little tiny operator in USA, that approach simply does not work because one, you have local number portability, so people just bring their phone numbers with them as they go. You know, I had a friend with a number from Washington State who was living in San Diego, and she lived in San Diego for like years and years and years and years, with a number from Washington State, which is pretty far away. And there are plenty of people who do that. That's totally normal, socially acceptable in the US these days for people to have numbers that are geolocated somewhere completely different than where they live. And people just carry the numbers with them. And also, if for someone like Themyscira Wireless, for an extremely small operator, where you all you get is just you go to a provider like bulk VS and you rent maybe 10 numbers, as opposed to a block of 10,000 numbers, which you would need for a full exchange range. So at that point, it's no longer possible to look at the structure of the number, the structure of the numbering plan, and immediately say, aha, this number is local. This is another one of my subscribers. Or no, this number is outside. You can't do that just from looking at the number alone. So we have to have a database. We have to have a little database that just answers the question. Is this number, is it one of ours or is it not one of ours? The database that just answers this question. And so here I'm saying, okay, so why is this database separate? Why not just use um, the HLR database? So here my idea was to have sort of like a layer in separation. So conceptually, when I go to Bulk VS web portal and fill out a form to purchase a phone number and have it added to my account, that is a separate, logically separate step from me subsequently assigning this number to a GSM subscriber. So when I set up Bulk VS initially, I went in there and I got a block of 10 numbers right there in my local exchange. But I have fewer than 10 GSM subscribers right now. So what happens to the numbers that are already rented, that are already yours, but haven't been assigned to a GSM subscriber yet? So, um, so yeah, the idea is that there is this separate database, and this is how it's implemented right here in the code. So from this paragraph onward, I'm just saying what MCC does currently when a mobile originated call comes in from Osmo MSC. Like the first two checks, is this does it have a structure of a North American number or not? Because if the number is not a North American number and plan number, then it has to be international. International can only go onto the outbound gateway. They can't go anywhere else. And if it is an ANT number, then look at it in the database. And the database will tell us, is this one of ours? Or is this not one of ours? And that's the routing decision. So we're going to switch it back to Osmo MSC using a replica of the internal MNCC code, or are we going to switch it out to Themyscira out? So, and then the inbound gateway. So the inbound gateway is a public SIP server. So I have a public IP address facing the outside world on a standard SIP port 5060, where I accept SIP packets from anywhere in the world. Anyone anywhere in the world can send um, can send calls to me, and but of course I only accept calls if they're going to go to one of the numbers on my network. So when a SIP invite comes in, my inbound gateway, the very first thing it does, it checks, is this number one of ours? If this number is not one of ours, it is statelessly rejected. So, and of course, every script kiddie in the world is going to send bogus SIP invite packets to any port 5060 they're going to find trying to dial calls to wherever. So they're all going to be statelessly rejected. Statelessly rejected meaning there's no resource allocation, so no vulnerability for DOS attacks. It just sends back a response saying nope, and that's the end of it. No memory allocation or anything. And only if the number is one of ours, only if the number actually belongs to Themyscira, then the stateful processing begins. It allocates call state structure. Everything else happens from there. Yeah, so that's a number database. So another point of complexity is, like I explained here, the number formats. Uh, so I no need to go through it in detail. The point is, this is one of those things where that's a difference between a quick hack versus a perfectionist. So I'm certainly in the perfectionist category. So for me, it was a very, very important goal from the beginning that the user experience on Themyscira Wireless has to be exactly the same as the user experience on a standard commercial cellular operator in the USA. So I have to support all these different dialing formats. And so the knowledge of these dialing formats is what makes the software North America specific. Circus has to support all of this, and that's why, let's say, if I were to disconnect ThemY MNCC and switch to the internal MNCC within Osmo MSC, well, at that point, all these different dialing formats will no longer work because the internal MNCC can only accept numbers that are in the exact same format as how they entered in Osmo HLR, not any other format. So that's why, for full perfection, you have to have this custom software that's very specific to local countries' telecom culture. Can't be, one size fits all. Mm, so, all right. So sharing, here I developed all of this work. Obviously, it'd be nice to see it get more use, but also, another point is, uh, like particularly the stuff in the first paragraph. I know this probably is the impression that a lot of people have gotten from seeing me on the mailing list and whatnot, how I often act like, I'm the only one in the world doing this. Please understand that this is my perception. I do not want to be the only one in the world, but if it feels like I am the only person in the world doing this, then I kind of react accordingly. So far, I just haven't heard from others doing it. So in this highlighted paragraph right here. So if there have been other people before me who took an Osmocom GSM network and interconnected it with their country's regular PSTN, like the full interconnection, not just a toy, but fully operational. I haven't heard of such people, but if such people do exist, please, I want to hear from you. Please share how you did it. I can only reason that you must have had to solve similar problems to all the problems that I've been solving here that I just outlined in this presentation. Okay, so how to, well, Rhizomatica would likely qualify. Well, the reason why Rhizomatica does not qualify is the use phone number NAT. Rhizomaticas, by policy, they have a number of policies that are certainly very different from how I do things. So one is the phone number NAT, that their subscribers do not get Mexican phone numbers as in 52 followed by 10 digits for every subscriber. As far as I know, they don't do that. And then, also they compromise on quality. I guess they don't consider the call quality to be a high priority if they transcode from one lossy codec to another lossy codec and God knows what. But of course, I mean, they're not in so-called first world, because I mean, Mexico is a big country. There are some parts of Mexico that are, almost first world like, and there are other parts that are not really, so they just don't hold themselves to the same standard. And also the whole guest roaming arrangement where they don't program their own SIM cards. People bring their SIM card from whatever. And of course, what about phone numbers? They don't have an actual roaming agreement. So someone has a citizen of Mexico could have a service, say from Telcel, which is the big national operator, and they could have a real genuine phone number on Telcel beginning with 52 country code, but they bring a phone to Rizomatico village, and now they're in guest roaming number, and of course they don't have access to the original Telcel number, so that doesn't really qualify. So the point still stands, and I haven't seen anyone doing in any other country anything similar to what they've done with Themyscira. But then, if there are people who haven't done it yet but would like to, and especially if you're going with a similar motivation, to be a replacement for commercial 2G service that is being taken away, um, yeah. Oh yeah. Carlson, the CCC event networks would qualify voice only though. Every subscriber has a fully qualified public German Ethernet 164. Yeah, this is definitely good. So maybe another day someone could give a presentation on how they handled all the same issues that I've had to handle. Although if those networks are temporary, if they're just for the duration of the event, maybe they wouldn't were putting as much effort into them as I had to put into mine. But anyway, if there are other people who would like to do something similar to what I've done, again, especially if you're coming from a similar motivation, then yeah, those people are my primary target audience, and I would love to see more people doing similar things to what I've done. It doesn't matter whether you use my software or you come up with some other technical implementation, but just doing a similar, solving similar problems, with similar motivator and coming up with workable solutions would be nice to see more people do that. So furthermore, on the sharing aspect, so here is the code. The code is public, but for anyone who has looked at this code, one thing you probably noticed that it's very different from most of my other software offerings. So all of my free Calypso software offerings have been very well documented. You have this doc directory where I very thoroughly document every single detail, and they are written so that to make it as easy as possible for people to install and use. This software is not like that. This software is written much more in the style of private software. So if you imagine if someone were to write a piece of code purely for their own use without any intent of ever publishing it, and then suddenly the code got leaked, it'll probably look pretty similar to what you would see in here. So you can almost think of it like I leaked my own personal private software, if you want to look at it that way. But so if someone is in USA or Canada, I don't know the names, but there are like a few smaller, very very small countries that also participate in the North American numbering plan plus one country code. If you're in one of those locations, you can just use the software as is, provided that you can deal with all the hard-coded paths and all the other Slackware specifics. But if you can get past those issues, otherwise the software should work. But then, if you are anywhere else in the world, there will be more changes required. And these changes would have to be preceded by a discussion on what is the right way. Because, again, what is the telecom landscape outside of NAND? I don't know the answer. And so, the assumptions about the NAND. So you have to have a different numbering plan. And what about the dialing formats? And if you're in some other country, what are your country's dialing format conventions? What are users used to with regular commercial operators? Do you want to replicate all that? How are you going to do all this? And then, of course, the database of locally owned numbers. So an absolutely critical piece, the software will not work without this database. You have to have a database that lists which numbers are yours. And so any number that's not in the database is considered to be not one of yours. And well, the format of this database is NAMP. It assumes NAMP numbers. So if you are in a different country's numbering plane, all of this will have to be adapted. And again, to be preceded by discussion. I'm very open to outreach. So if there is somebody out there who likes what I've done and they want to replicate it in some other country in the world outside of North America, please reach out to me. Explain what you're doing, explain what country you're in, what your telecom landscape looks like, and maybe we'll figure out some way. Maybe we can find some way to generalize the software so it can support both North American arrangement and whatever else you have. So, but it would have to be discussed with whoever wants to deploy it somewhere else. Um, so, all right. So SMS. So most of this talk has been about voice, but SMS is of course an issue. And you heard from Denver earlier, who's again, thank you, Denver, so much for providing SMS interconnection. Without you, this would not have been easy at all. And but in technical terms, I am still developing, just beginning to develop SMS software. And here I explain why the built-in SMSC is not suitable. Just like with calls, you have to have all these different number formats, and you have to understand, okay, is this number one of our subscribers, or is it somebody, or is it outside world? So again, I have to look up in a database, and then the different run SMPP role, because SMPP is client server, it's asymmetric. I need an SMPP client, not SMPP server. And of course, it has to be an SMPP client that runs as a daemon, the way if the connection is broken, you have to immediately reconnect, to do all of those things. So all that remains to be implemented. I'm just starting to work on this. And so I'm sure some people here have seen my patches in Garrett for OsmoHLR, to where this is the ticket here. The ticket 6135 is what I've been working on, because here again, I'm trying to replicate the architecture of traditional commercial networks as closely and as accurately as possible. So in traditional networks, the SMSC is a separate network element, and you have, basically SMSC is the thing that does the store and forward. So you have the SMRP, the relay protocol, where messages go from a mobile station to the SMSC, and then from an SMSC back to a mobile station. Those happen in real time. So, in order for a transfer from the mobile station to SMSC or the other way around, in order for that transfer to take place, both the mobile station and the SMSC has to be up and working at the same time, and real-time communication. But once that real-time leg is done, then SMSC can do store and forward, can deliver to to the destination hours later, days later, whatever. So, I definitely seek to replicate this architecture, and I like having, because I don't do guest roaming, I program my own SIM cards, and in my own SIM card programming, I want to have a valid looking SMSC address. I use a fake made up global title, because the structure of North American numbering plan, there are some number ranges which are reserved invalid officially, so I make up a fake global title that's going to be my SMSC address. And so when I saw that one can do SMS over GSUP, mimicking map, I thought, okay, I like this. This is exactly the way I want to do it. And then I saw that Vadim was the original implementer of that feature. I was like, yay, Vadim is. Vadim is a very good developer. I like his style. I figured, okay, well, I'll just extend some SVG up, make it work better. And so this is the current ticket in Redmine, tracking my work here. So the OsmoHLR patch is almost done. So yes, acknowledging to both Harold and Pau, yes, I see that you're basically saying that all I need to do is just change the del to free in the naming, and the patches will be good to go. So I'll make that change after the presentation. So Osmo HLR will be done. And then I also have Osmo MSC patches related to this ticket. They're on my they're on my branch. The branch is, of course, published. It's the Falconia OS 6135 branch, but they need to be also rebased to master, submitted to get it passed through review. So that we'll be working on that next. And then the actual SMSC. So for the actual SMSC, as I was talking to Vadim about this earlier, the concern was that right now Osmocom project does not have a separate Osmo SMSC. There is a desire for Osmo SMSC, but there is no implementation. And so when I was telling Vadim that I plan on implementing my own separate external SMSC, the concern again was, well, if I make it specific to North America, just like the software that I presented already is North America specific, wouldn't that also hamper its usability? So I mean, the answer is multi-part. So first of all, as far as my already existing voice software, the reason why it's North America specific is not because I wanted to be mean and difficult and just wanted to make it North America specific just for the heck of it, but because it's a necessity, because there are so many things that are specific to local telecom culture in each country. And the same holds for the SMSC. So ThemY SMSC, which is what it's going to be called, will by necessity, the complete solution will by necessity be specific to the North American environment, and it will have to look up in ThemY local number database, because that's the only way to determine if the number is local or not. So if you're handling a mobile originated SMS, a mobile originated SMS came in, and the very first thing you're trying to do, okay, is this going to another subscriber in my local fiefdom, in my local domain, or is it going somewhere to the big bad outside world? That's the very first routing decision you have to make. And how can you make that routing decision without some knowledge of local, what your local dialing formats are? Because again, so, the same number can be entered three different ways. If you have a subscriber whose number is, using the example number range, 310-555 or 101, that's the range like they use in movies. You can enter that same number in three different ways. You can enter it just like that as 10 digits, and you could put a 1 in front of it, and you could put a +1 in front of it, and all three have to be recognized as being the same destination. That's a mandatory feature. So how can you do this in a country agnostic manner without being North America specific? And then once you've grokked the number format, then you have to decide, is this number one of your local subscribers, or are you going to the outside world? So these are specific decisions. But what I will do, however, when I implement them YSMSC, I will use Osmocom libraries. I'm not going to use Auto Tools, but other people can Auto Tools magic later. I will use Osmocom libraries, and I'll use the newer dialect of C, similar to as close as I can manage to a standard Osmocom coding style. And so it should be possible for someone to take the YSMSC, strip out its North America specific parts, and maybe make it a little bit less perfect, and turn it into Osmo SMSC. I mean, that's a thought. It's a possibility. But again, it's just a plan for now. I haven't even started on that code yet. So we can have a discussion. So timeline. Oh, I got the time pressure I'm working on. So basically, you can see on the slide exactly what is happening. So, I am a very, very devoted user of 2G. Uh, there is this saying, I would rather, how does it go? I would rather die on my feet than live on my knees. And I am very much that type of person. I absolutely refuse to bow down, roll over, and obey society's edicts. So when the major carriers in the USA are shutting down GSM 2G service, and tell everybody, you got to get a new phone, come to our store, we'll give you a free latest iPhone with 5G, Like, no, I will not. I will not accept your modern phone. I would rather have no working phone at all than use a modern phone. And but I like to keep my GSM. So I've already been heavily using my Themyscira wireless network. So I think Keith at one point asked me, well, who you keep saying yours is a production network. Well, who are your users? What kind of production network is that? Well, I'm the user. I use the Themyscira wireless network with an end user hat on. Here at my home, where I'm sitting right now doing this video presentation, T-Mobile service, it still exists, but the quality is atrocious, so bad that it's barely usable. And so I use my Themyscira. I mean, this right here, this is a Pirelli DPL10 phone, and it runs on Themyscira. I don't know if you can see, but you can see my made up MCC MNC on there. So, and if I'm talking to one of my family members, I'm using this network. My boss from my day job used to call me. I gave him the number that goes to my Themyscira network. So I really use it with an end user hat on. It's a production network for me now, even though its quality is still, well, I mean the quality is good, but it's not like fully productionized yet. I don't have SMS. I don't have, the login mechanism is still not that great, and I don't have the VTY mechanism and all the long running processes to debug issues. And every now and then I get weird issues with packet loss and jitter, and because I don't have a VTY like path into my ThemY MGW, it's really hard to debug those. So there's still like lots and lots of things that need to be improved, but I'm already using it with an user hat on. So this is kind of the situation. And yeah, I am using the 2023-02 stable release of Osmocom CNI. I can't really even test the newer stuff because, yeah, this is the situation. And let's see, is this my last slide? Yeah. This is my last slide. So again, please, the people whom I offended with my abrasive attitude toward the SDPification developments and Osmo MSC, please accept my apologies. But I'm like, I know it's a metaphor when I say I'm working under the gun to my head, but that's what it feels like. What T-Mobile is doing here to people like me. So basically, to be able to test the new Osmocom CNI code, I will need a separate test network. Now, thank you, Harold. Thank you, Harold, for the subsidized hardware. That's very, very helpful. I still need to do like a lot of work to put it all in use. I still need to. I have this guy I was trying to hire to do the GPS antenna installation, and he flaked out on me. So now I have to find somebody else who can do it. Uh, so, and again, there are all these digraph dependencies on other parts of the work. I may or may not get to the test network setup before will shut down. So for a while, I'll keep running with the 2023-02 stable release, February stable release of CNI. I just have to keep using for now. But eventually at some point, I will have a separate test network, and that's when I'll update the latest master on all the Osmocom CNI projects and thoroughly test everything and figure out, okay, what works, what needs fixing. And so that's kind of the end. So now it is time for Q&A.
Yeah, first of all, thanks for the presentation. It was a extended journey. Let's see who has some questions.
Someone's typing. Alejandra is typing. Okay. Okay, are the recordings of the previous meetings available? Yes, they are. They are linked from the OsmoDevCall wiki page. Oh, I provide the link. Um, Harold, maybe you as the moderator could answer Alejandro's
Sure.
question.
Yeah, sure. Okay. Since nobody else is bringing up questions, let me just maybe, I'm sure you are aware, but it sounded a bit like the codec selection is overly complicated in Osmocom. The reason why it is so complex, of course, is on two, at least two aspects. One of them being that, all the real production networks in which Osmocom software is deployed, they have to worry and care and primarily care about AMR. So that brings AMR to the equation. And secondly, also, we have now a 2G versus 3G codec selection as well in the picture, which again makes things significantly more complex. So that maybe just a remark from my side that why is it so complex and not so simple like in your network?
Well, yes, and let me add another little point to that, especially when you mentioned the 2G and 3G interworking. Just to make people aware, is if you run a network where you support both 2G and 3G, and in that case, the transcoding may be necessary because let's say on the 2G side, you have someone who brings in a very old phone that does not support that does not support AMR, and we're not talking all that old. There were some vendors as late as early 2000s, possibly as late as 2002. There were some mobile station implementations that only supported up to EFR and did not support AMR. So if someone has one of those mobile station implementations, phone handset development board, whatever, on the 2G side, and of course the 3G side requires AMR. 3G, when the phone, because even though the actual chipsets, actual phones, a 3G phone is in reality a 2G plus 3G phone, so the chipset inside has full support for the legacy 2G codecs, but when it's connected over UTRAN, it's not possible to use any of the older GSM codecs. It's only possible to use AMR on UTRAN. So if you have, that kind of combination, an old GSM phone on one leg and a UTRAN connection on the other end, the only way to make the voice pass is to transcode. So again, I'm pointing out that the policy of no transcoding ever may not be so great.
Yeah, okay, since we don't have any other questions, well, thanks again for your presentation. Maybe one final remark from my side. There's also a completely different way of dealing with call control in various different telephony standards, which is the OsmoCC by Jolly. I'm not saying it solves any of your problems. I just wanted to bring it to your attention in case it's not something you've seen so far. And Jolly is also here on the call, so just wanted
Well, actually, if Jolie could, because I've heard about it from Vadim. Vadim and I had extensive discussions about this, and Vadim told me about the existence of OsmoCC, but it's just that. Vadim told me that it exists, but no details. So, Jolie, if you're here, would you be willing to give a little bit of like a quick comparison of how it differs from what I've implemented, and pros and cons?
Okay. Yeah, apparently bad timing. He just brought it. He just came in from a drive from Berlin. Yeah, it's different topic. I know he was traveling quite far today and picking up retro networking hardware, so not a good time right now, apparently.
Gotcha.
But yeah, I mean, it might be a good, and I think I suggested that also already. It might be good to have maybe an OsmoDevCall about OsmoCC at some point.
Yes.
Maybe we
Nice.
already had one and I forgot about it, and then I sincerely apologize if that is the case. Let me just go back to the. No, it doesn't look like we already had one, so it might be a good idea to see if Jolly can spare some time to do that at some point in the future.
Yeah, it would be good. I would appreciate hearing about it. And also, while we are on the subject of what other topics would be appreciated, again, this person who was posting on OpenBSC mailing list, I believe Enzo is the name. I'm sorry, I don't know if Enzo. I can't tell the gender from the name, so I can't assume one way or the other. But the person who was talking about all those proposals was also in USA and was talking about a completely different way of interconnecting to PSTN. I would really like to see a presentation from this person. So, looking at the OsmoDevCall schedule, it looks like there is nobody scheduled from October onward. So please, you'll be more than welcome to give your own presentation here and present your own way that's different from what I presented. This way, we can all learn from each other.